Imagine a hybrid car waiting at a red light. The engine is off, conserving fuel, but the car is ready to move the moment the light turns green, because it has a battery to provide the initial power, allowing the car to start moving efficiently without idling the engine. Now, what if we could apply that same concept to the electricity grid? This is the idea behind the Hybrid Gas Turbine project at ENMAX Energy's Crossfield Energy Centre, funded by the Government of Alberta through Emissions Reduction Alberta. Like a hybrid car, the hybrid gas turbine has a battery that's ready to respond instantaneously to the grid when it's needed, while keeping the gas turbine turned off until it's absolutely necessary. That way, the turbine doesn't need to run continuously while still providing spinning reserve, conserving fuel, and reducing emissions. When more power is required than the battery can provide, the gas turbine smoothly spins up and takes over. This approach not only enhances grid stability, it also significantly cuts down on greenhouse gas emissions by reducing the need for simple cycle gas plants to idle at low power when providing spinning reserve. It's a great example of how to integrate advanced energy solutions into the grid to make better use of existing generation assets while reducing emissions. Now that the project is complete, we sat down with Greg Conlin, Vice President of Operations at ENMAX Energy, to discuss how this technology works, the successes and learnings from the project, and the impacts this first-of-kind facility is already having on Alberta's grid, as well as the potential it holds for the future of sustainable electricity production. Here on Carbon Copy. Well, we're really excited to have you with us this morning, Greg. Maybe by way of getting started, could you please briefly introduce our listeners to ENMAX and what it is you do?
Yeah, sounds good, Chris. I'm very excited to be here and talk about some of our projects. ENMAX is a leading provider of electricity services, products, and solutions across Alberta and within Maine. ENMAX is a little bit unique. We do have 3 different business units: ENMAX Power, ENMAX Energy, and Versant. And they operate across the value chain in electricity and energy. We have a regulated wires company, a competitive generator, and our retail energy provider. And what you'll find throughout ENMAX is our team members are really dedicated to both safely delivering reliable electricity, but constantly looking for opportunities to both innovate and improve our operations. And that is reflected in our corporate values. Within ENMAX Energy, where I work, we produce over 1,500 megawatts. That comes from 5 different gas-fired power plants and 3 wind farms.
I think before we dive into the specifics of the project we're here to talk about today, longtime listeners will know that I'm definitely an electricity system nerd, self-described. But I think it's important, we're going to get into some pretty deep technical concepts today. So what I'd like to do is just start out with a bit of a Energy Grid 101 and understand where we're coming from, and that'll really help us set the stage for understanding what this project is all about. Could you maybe take us through a bit of background?
Sure, and I agree. We could probably spend this whole podcast talking about the intricacies of a integrated power grid, but we'll try and keep it simple. The base concept is there are producers of electricity and there are consumers or users of electricity. And the energy market is designed to balance the production of electricity with the demand in real time. So supply always has to meet the actual demand of consumers. Anytime a customer or consumer turns on a light switch, there's a power plant throughout Alberta that must increase its production just a little bit to make sure that the energy system is in balance. But in addition to just the energy that's provided, you have to ensure you have a reliable and stable power grid. So there's also products or ancillary services that are used. And that's the main focus of what we'll talk about in the hybrid gas turbine project. So ancillary services are there to provide grid stability in the case of change in both load or production. So one product that is out there is called spinning reserve. And what will happen is traditionally a fossil fuel power plant or a hydro facility will run at less than full capacity, but is still online and generating power. So that in the event another power plant trips off, or a change in maybe renewable resources, that spinning reserve asset can immediately ramp up and take over that load. And that's important to ensure voltage and frequency stability across the province. So the project we're going to be talking about is the hybrid gas turbine at the Crossfield Energy Center. And it's novel because it doesn't need to actually be spinning and still offer spinning reserve characteristics to the grid. And it can achieve a reduction in GHGs while doing that.
And that's a great segue into what we're going to be talking about for the bulk of today's episode. So, as you said, spinning reserve that doesn't spin. That sounds like a really, really interesting concept, and I can't wait to talk about it more. So why don't we dig into the hybrid gas turbine project? Now, ENMAX recently received funding and successfully completed its project to undertake a groundbreaking installation of a new battery energy storage system at the Crossfield Energy Center here in Alberta. So can you maybe just give us the high points on that project, what the motivation was, and what the outcome was of ERA funding?
For sure. And like I said, we're very excited. We do like to talk about the hybrid gas turbine installation and project. A hybrid gas turbine uses an actual grid-scale battery to provide the initial startup power and production to the electricity grid when it's needed. You can think of it as a hybrid car sitting at a red light. The battery is available when you need it, but the engine is sitting there and not idling. So as you accelerate from that stoplight, the battery is producing, and then the engine will start up and take on that load. So hybrid gas turbine allows for the battery to provide instant on-demand electricity when needed, without the gas turbine idling and actually consuming fuel. So when it's providing a spinning reserve product and gets called for that energy, the battery will start to provide power to the grid as that gas turbine starts up. So we were first introduced to this concept back in 2017 when our engineers were meeting with GE, and they had just deployed the first hybrid gas turbine down in California. Since the Crossfield Energy Center also uses GE gas turbines, it seemed like a good opportunity that we should explore. Crossfield Energy Center is what's called a peaking facility, so it actually only operates and comes online in periods of high demand, which means it's actually sitting idle a lot of the time during the year. And one of the ways we thought we could utilize that asset more often in the market was to be able to provide this ancillary service of spinning reserve all the time.
Wow, that was a great overview, Greg. Thanks so much. And I think that's the last point is really important for our listeners to understand is that, I think we imagine the grid as all of these generators that are always working. But in fact, most of the generators, most of the assets on the grid are sitting there idle for a good chunk of the year. And it is, through technologies like this that we can really optimize our grid and get the best use out of those assets. So I think that's a great way to think about it. Now, Greg, you mentioned you've been at ENMAX for 12 plus years. Can you maybe speak to the significance of this project, as a first of kind, as a initial deployment of this technology? But certainly your fleet of generators, as you mentioned earlier, is much broader than just Crossfield. So just maybe give us the context of this project in light of the broader ENMAX fleet.
For sure. The project really just shows ENMAX's commitment to innovation and the energy transition in Alberta. The technology is allowing us to actually utilize our existing asset base while incorporating the latest technology in lithium-ion batteries to increase efficiency and reduce our overall emissions. So the idea of investing in high efficiency or low emitting assets has been within ENMAX for a long time. Like you mentioned, I've been here for 12 plus years working with ENMAX Energy. In that time, we built the Crossfield Energy Center, which was using the latest GE gas turbines, which was the LM6000 PF. Very, very low NOx emissions without actually consuming water like some other traditional turbines. We then went on to build the Shepherd Energy Center, which was a first of its kind 501G unit within Canada and is still the most efficient combined cycle plant in Canada.
Great, thanks for that, Greg. And I think that's really what we're all about here at ERA, which is thinking about, okay, Alberta has this amazing base of industries, of power generators. How can we use new technologies to better leverage those assets to provide a better outcome for the province? And so I think this project, hits the nail on the head in that regard. Why don't we dig a little bit further into the technology and what makes it unique and what made this a true first-of-kind project in Alberta? In practical terms, what does it mean to add a lithium-ion battery to a natural gas turbine? I think a lot of our listeners will be familiar with lithium-ion batteries in the context of electric vehicles or in the context of batteries sitting by themselves connected to the grid. But what does it really mean to integrate it with an existing power plant?
Yeah, the hybrid gas turbine really at a high level only consists of three different components. You've got your traditional gas turbine, you've got a lithium ion battery storage system, and then you've got this integrated control system that coordinates the two. The battery we actually installed is just really a scaled up version of the batteries used in most EVs. It is 4.3 megawatt hours with a 10 megawatt peak power production. But what is really novel and the unique part about the technology is the control system and how it actually coordinates the two. Like I mentioned before, when you get called to provide spinning reserve, you want that energy ramping up as fast as possible. So the battery will immediately begin to discharge. And as that battery discharges, you're starting up your gas turbine, which takes between 5 and 10 minutes to get online and start producing electricity. As that electricity comes online, the gas turbine will ramp up. The battery will actually ramp back down and begin to recharge using the power production off that gas turbine.
Much like a hybrid gas car that you talked about earlier. And I think that's a great metaphor for the project that'll hopefully help people understand how cool this concept is. Now, you mentioned that this was only the second deployment of this technology in North America, the first in Canada, and certainly the first in Alberta. So can you maybe speak to the role that technology development and de-risking, the pathway that this technology has had to go through? Why hasn't this been done before, and what does the future hold for this technology?
Within Alberta, traditionally we've got most of our power generations from coal-fired and fossil fuel-fired assets. So there's lots of opportunity out there for the spinning reserve product or ancillary services to be provided from those different generating assets. As those assets have started to come offline or be converted and renewables have started to pick up throughout Alberta, the need to find different ways to provide these ancillary services has become greater and greater. And like I mentioned, this was a first of a kind in California, and then ENMAX was able to deploy it and be the second of a kind and first in kind within Canada.
Maybe one more question about the project, and you've already touched on it, but if you can just elaborate on how this type of technology, if it were to be broadly deployed, how does it affect the grid and the people and businesses that rely on our reliable and affordable electricity system here in Alberta?
Yeah, it has an overall positive impact on all Albertans in a couple of different ways. Number one, it's helping to ensure a reliable electricity supply that I think everybody needs and wants, but also it's doing that at a reduced emissions. So we're reducing the amount of GHGs that we produce to provide that same product. The deployment of storage and this kind of technology has also started to pave the way for other storage to come online and be utilized within the province.
Yeah, and I think that's a great point. You know, when we funded this project, it was probably the third or fourth energy storage project in ERA's portfolio, and certainly one of the first few to actually get built here in Alberta. And since then, we've seen rapid scale up of the energy storage industry writ large in the province, and we're very happy that this project is one of those steps along the way in terms of de-risking the technology and proving out that, yeah, these grid scale batteries really do work in Alberta. And like you say, they do provide those benefits to the system, which at the end of the day is what we're all looking for. Industrial scale carbon capture. North America's first hydrogen-powered locomotives. Using drones for reforestation. Since 2009, Emissions Reduction Alberta has been helping to deliver on the province's environmental and economic goals by investing in projects just like these. Projects that pilot, demonstrate, and deploy clean technologies across our industries. Whether it's detecting methane from space, producing biogas from Alberta's agriculture industry, or one of almost 300 other projects in our portfolio, ERA's investments in these game-changing technologies are reducing emissions, lowering costs, attracting investment, and creating jobs right here in Alberta. ERA's funding is sourced from the Government of Alberta through the Technology Innovation and Emissions Reduction, or TIER Fund, which is Alberta's provincial industrial carbon price. For more information about Emissions Reduction Alberta, visit eralberta.ca. Now, ERA provided $7 million to this demonstration project. Obviously, this was a decision made a number of years ago, and we've since successfully completed the project, despite a number of challenges that we'll touch on later in the episode. But maybe if you can take us back to the moment when ENMAX decided to put in the proposal to Emissions Reduction Alberta for the project, can you just speak to what you were hoping to achieve and how you made the case, and then how that actually turned out. So how did the project achieve those outcomes, and was it successful in your view?
Yeah, when we first came to the area with this project proposal, we did have a few key objectives that we wanted to make sure that we achieved. The ability to provide this spinning reserve product with a reduced GHG footprint was very important. We wanted to demonstrate ENMAX's vision on being Canada's leader in the electricity industry. We wanted to overall advance the industry knowledge within Alberta about storage and new technologies like this, and we wanted to start preparing the workforce of tomorrow. So I think we've been very successful in the project and those outcomes. Last year, the hybrid gas turbine produced over 3,000 hours of spinning reserve time, so that was at a reduced GHG footprint. This was one of only 2 storage projects in Alberta at the time, and it was the first of its kind anywhere in Canada. Through this project, we actually have worked with industry. We've worked with the Alberta Electric System Operator to actually integrate this technology into the grid, and we've really found it a benefit and allowed other storage options to come online. Like I said, back then there was only 2 projects in the Alberta grid. There's now over 10 projects operating, providing 190 megawatts of electricity to the grid. Another thing we're very proud of is preparing the workforce of tomorrow. In the project, ENMAX actually stipulated that the project used local contractors to complete the construction phase. And those local contractors gained knowledge in installation of battery systems at our power plants. We also had our own engineering team, operators, and maintainers deeply involved in the project, and they've gained the knowledge that's going to allow us to take that technology to other plants within our fleet.
That's so great to hear. I think that's an underappreciated reality of some of these first-of-kind projects, is that some of that experience maybe didn't exist prior to the project, and it's only by doing the first one that we can actually get people trained, get folks experience with the technology, so that, like you say, it can hopefully be proliferated in the market. So I'm really happy you touched on that point. Can you maybe just speak to the business case for this project, or let me put it a different way, the value of ERA funding in making this project a reality? We funded about 50% of the total cost, and as you mentioned, it was sort of at the time a fairly risky first-of-kind project. How essential is that ERA funding to make projects like this happen?
Yeah, the ERA funding was absolutely essential in getting this project off the ground. Within Alberta, we operate in a competitive market, so you must make all of your returns within that market framework. Taking risks on emerging technology is sometimes difficult without some additional help and funding, and that $7 million went a long ways in helping de-risk this project. The project has been a great collaboration between ERA and ENMAX. It's really going to inform how ENMAX looks at potential application of storage in the future at our new or existing facilities.
Now, we've touched on it a few times, but given that we are Emissions Reduction Alberta, I'd be remiss if I didn't dig just a little deeper into the greenhouse gas benefits of the project. Now, for a project like this, where we're providing services to a very large and complicated system like the power grid, I know calculating GHG emissions is a bit of a complicated endeavor, and we could probably spend an entire podcast talking just about that. But maybe if we can dedicate one question to it, how can you explain how this technology helps to reduce greenhouse gas emissions and save energy in the context of the grid?
Yeah, the hybrid gas turbine helps reduce emissions in a couple of ways. With the addition of the battery, don't have to run the gas turbine all the time while providing the spinning reserve product. This reduces the overall runtime on the turbine and allows our other facilities to run at more optimal, higher loads, higher efficiencies, rather than being pulled back to provide that spinning reserve service. Now, if you're to compare Crossfield to a facility that operates similarly but without the battery, we estimate it would save about 45,000 tons of CO2 equivalent every year.
Wow, and that's just one battery on 1 out of 3 turbines at the facility, if I'm not mistaken.
That's correct. We chose only to install the hybrid on one gas turbine so far, but there is the ability to expand that to the existing other 2 turbines at Crossfield or at one of our other facilities.
Precisely, and just for our listeners' context, both within the ENMAX fleet and with other participants in the Alberta market, there's dozens of these turbines online, and so that just helps illustrate, I guess, the scaling potential of this technology in a best case scenario. So that's really exciting. I really like the point about how this technology achieves benefits not just at the facility where it was installed, but because ENMAX is an operator of a fleet, it allows that sort of cross-unit optimization. And I think that's going to become increasingly important as, again, we continue to see load growth on our grid. We're continuing to try to provide reliable and affordable energy in the best way possible. Trying to understand how we can optimize all of our assets in the system to provide those services is such an important issue. So again, very happy to hear that this technology helps contribute in that area as well. All right, so far we've talked mainly about all of the benefits and the great things that happened in the project. But we know, like any of ERA's investments or any first-of-kind project, there are going to be challenges and bumps along the way. So could you maybe speak to some of the challenges specific to this project, and as well how those have led to impactful lessons learned and takeaways from this first-of-kind initiative?
Sure. One of the early and interesting challenges that we didn't anticipate up front was actually getting approval to offer our hybrid turbine within the spinning reserve market. The electric system operator within Alberta has a technical specification that you must meet to offer spinning reserve. Now, that technical spec was written long before anybody had actually contemplated or envisioned a hybrid gas turbine. So it didn't nicely fit with those requirements. Our engineering team did a great job in collaboration with the ISO throughout the project and throughout the commissioning and testing phase to make sure that they were comfortable that the technical characteristics would be the exact same as an actual spinning reserve traditional asset.
Yeah, that's, I think, one of the most important takeaways from this project.
So in the end, we did obtain formal approval for battery-based assets to provide spinning reserve in Alberta, and this really paved the way for other participants to enter this market.
Yeah, I'm not sure the ISO would agree, but one of my favorite things is when an ERA-funded project leads to a revision in one of these regulations, because it really means that we're pushing the envelope on the technology and we're bringing new solutions to the market that the market needs. So I think this project is a great example of collaboration between yourselves, a participant, the technology developer, GE, and then the system operator, all three of you working together to make sure that the technology could and would provide what the system needed. So I think that's a great takeaway from the project. Thanks for that. Another question or another challenge that I know has come up with the project, obviously this is one of many projects in our portfolio that was delivered over the past few years, and we know there's been no shortage of challenges globally, whether it's the COVID-19 pandemic, geopolitical disruptions, supply chain disruptions. So can you maybe speak to some of the logistical and supply chain challenges that were encountered in delivering this first-of-kind project?
We probably couldn't have picked a worse time to try and deliver such a novel and complex project in Alberta. It was right in the middle of the COVID-19 pandemic. We had issues from supply chains to labor to remote work to you name it. A lot of the components within the battery system came from overseas. Delays in shipping and delays in manufacturing led to an overall delay in the project. One of the kind of interesting things that we learned about is that batteries can't just be stored forever. You have to maintain their charge and you have to maintain their temperature in order to keep their reliability up. So we actually received the batteries long before we received any of the other ballast supply equipment. So we had to come up with a way to keep the charge up on these batteries while we waited for the rest of the project to arrive. And it's just something we had never considered, and just another learning about how we incorporate storage within our assets. We had trouble getting the expert labor or expert engineering across the border during COVID-19. So like everybody else, we were deploying remote work methods where our engineers were on site talking to a GE engineer someplace in the United States and trying to commission equipment, which just led to some challenges and some delays in getting the project online.
Wow, so many, hopefully unique challenges faced by the project, but I think, amazing to see the project come through and succeed despite all those challenges. And again, that's part of why ERA invests in these projects, because that patient capital and the ability to support through these kind of disruptions is something that we hope is really sending the right signal to investors to be able to deliver on these somewhat riskier first of kind projects here in Alberta. So I would say amazing work to you and the team to persevere through those challenges, and we're very happy to see the project come out the other side successfully, and at the end of the day with great performance in terms of no lost time incidents and just a great overall record of delivery despite the challenges. All right, so from here we'll pivot a little bit to speaking about what comes next, and I think we've alluded to it a couple times. There seems to be great potential for the technology here in Alberta if the market continues to be supportive. So now that we have the first commercial hybrid electric gas turbine in Alberta, in Canada, what does ENMAX see as the next steps for this technology in terms of expansions, upgrades, future projects, or whatever else might come to mind?
Yeah, we think the technology could be used and installed on the same gas turbines that we have across field, filling out the other two, or deploying it at wind assets or one of our other thermal plants. This has really just given ENMAX the knowledge and the comfort to kind of explore the storage space more.
We're continually looking for ways to meet our ESG target of a 70% reduction from our 2015 emission levels, and we've made some good progress on that so far. The hybrid gas turbine is just one way that has helped facilitate that.
So far, we've actually been very successful. We've reduced our portfolio emissions 65% since 2015, and the hybrid gas turbine has helped facilitate that.
Yeah, it's really tremendous progress, and we're happy to have supported ENMAX in a couple of ways along that journey, and look forward to doing so again in the future. So now that we've successfully come through this project and we have our first commercial hybrid electric gas turbine operating here in Alberta and in Canada, what do you see as what's coming next for ENMAX in terms of expansions, upgrades, other exciting projects that are coming, and anything else that really excites you about the future as it pertains to this technology and your fleet overall?
Yeah, we think this technology could be deployed either at some of our other assets, particularly something like a wind asset, or equipping our other two gas turbines at Crossdale with the hybrid option.
We are constantly looking for ways to meet our ESG goal of a 70% reduction from our 2015 levels.
So far, we've done very good on that goal. We're currently sitting at a 65% reduction from our 2015 levels. And the hybrid gas turbine has just helped contribute to that improvement in our emission levels. What does the future hold? We're going to look at other opportunities to both expand or upgrade our current facilities, looking for different and new technologies to install in our gas turbines to increase their efficiency, which will bring down our overall GHG emissions. We're currently actually doing a study at our Hybrid Energy Center around the feasibility of carbon capture and sequestration. That has been a partnership again with ERA, contributing to some funding. And that hopefully will inform us on what is needed in terms of technology and capital investment to really capture all the carbon that's being emitted from that power plant.
So a lot of exciting work coming down the pipe, and we're very happy to be partnering on some of it. And I'll say I think I speak for ERA when we're excited to see what comes next, because the power sector is constantly changing.